Hello all, this is Michelle Peltier and I'm going to be demonstrating a think aloud for you using solving absolute value inequalities. Hello all, this is Michelle Peltier. I'm going to be demonstrating the think aloud using solving absolute value inequalities. So when I look at an absolute value, I know that an absolute value is a positive number. I also know that it represents a distance from 0. So if I go on my number line from 0 units to 3 units, I know that distance is 3 units. I've also learned there's another number on that line that is also 3 units from 0, and that's -3 is 3 units from 0. So therefore, I can also make the conclusion that the absolute value of -3 is 3. When I look at it as a variable, and it goes to this level, and we're still thinking about that distance from 0, now I don't know what my value is, but I know that its distance is equal to 3. So if that's the case, and my distance is going to be 3 units from 0, I could go on my number line, starting at 0, and count over 3 units to 3, so that I know x is equal to 3. I also know if this represents my distance, and it's got to be equal to 3, I can go 3 units to the left, and that will also be equal to 3 units from 0. So therefore, x could be -3 as well. With that thinking, it's easy to just assume that we can say, well, x is 3 and x is -3. But what I really need to know is what I'm changing is this value inside here is that distance. And that distance being a +3, but it represents a -3. So that's really what I'm looking for. So when I go to an inequality and I look for that distance from 0 again, when I see that absolute value, if I want that distance from 0 to be greater than 3, I know on my number line it would be any values that are this way, farther than 3 units from 0. So I know that x values could be greater than 3. But I also know the distance from 0 being over here at this -3, that they could be over here. But these numbers aren't -3. So what I want to do is I want to look at this value. The negative, whatever those values are, must be greater than 3 units from 0. So that's where it comes in, looking at this being what's the negative. It's the distance from 0 that we have to change the sign on. And so I know x is greater than 3, and I know x would be less than -3 when I divide by my -1. And then it's very easy to notice from my number line. I could do the same thing if I'm looking for less than. The only difference is on my number line, I'm looking for these values that are inside here. Or, because it's absolute value, I would be looking for these values inside here. Both of these values would be representing my x. So these values being positive, that would be a positive x would be less than 3. These values being negative values would be negative x is less than 3. Notice there's nothing to do on the left. These are going to give me these values automatically. And this one, when I divide by my negative, that's going to flip my symbol, and my x values would be greater than -3. So that would turn into these values on my number line between 0 and -3. Now, the reason I really need to know that is because let's see what happens now. When I move on to something like this, notice it gets harder, and it's a whole lot more difficult to understand when I'm looking for that distance from 0. I'm still considering this to be a distance from 0. So if we're looking on that number line, notice I'm doing the same thing no matter what level I'm doing it at. If I am 5 units from 0, this would all of this stuff that's 5 units from 0 would be less than or equal to 5. All of this, notice, has a negative value. I need to make the distance to become negative and be less than or equal to 5. And I'm only having to change the negative here. I don't have to worry about this sign. It will take care of itself. It's a whole lot less to have to remember if I only have to change one sign. Now when I distribute, I get negative x plus 1 less than or equal to 5. When I solve, negative x less than or equal to 4. And then when I divide by my negative 1, x becomes greater than or equal to negative 4. Also here when I solve, x, no change in my symbol. When I add 1, x is between 6. And both of these numbers would be my endpoints on my number line. And since I'm doing less than, I would be at negative 4 equal to, I would be at 6 equal to, and it would be the in between because it's greater than negative 4, but yet it's less than 6. And notice these are a distance of 10 units apart, which is where I got my distance from 0. My 0 would be the middle between those two. They're an equal distance from that value. So, same thing here. I don't have to do anything other than change that distance from 0. X minus 1 greater than or equal to 5, and negative x minus 1 greater than or equal to 5. I'm only having to remember the one thing. So x greater than or equal to 6, and negative x plus 1 greater than or equal to 5. Move my 1 over, negative x greater than or equal to 4. So x is now less than or equal to negative 4. Notice what happens now. My problem has now gotten a whole lot larger. There's a lot more to think about, but I still have an absolute value. I still have it equal to a number. So I can still do a distance from 0. My process doesn't have to change. The only thing is I have to get my absolute value bars by themselves first. So I'm going to move my 8 over and have 6, 4p plus 2, less than 42. Divide by my 6. Now that I've gotten my bars by themselves, less than 7, I can now solve it exactly like I did everything else. It's no different. 1 as is, 4p plus 2, less than 7. The other one, changing that distance, negative 4p plus 2 to make it that negative value, less than 7. When I solve, subtract my 2, 4p is less than 5, so therefore p is less than 5 over 4. Distributing my negative, negative 4p minus 2, less than 7, negative 4p, less than 9, so p must then be greater than negative 9 over 4. So I hope me walking through this and letting you see how I think through a problem will help you to be able to think through a problem and maybe help your kids along the way as well. Good luck, and let us know if you have any questions. See one of your instructional coaches or ask one of your high school instructional coaches, and they can certainly help you out and would be very willing to do so. Have a great day.